Hello and welcome to this video on measures of variation. We're going to focus this particular one on how to work with both variation and standard deviation. So let's begin. The first thing what we need to consider when we're working with mathematics is that the variation is usually measured positively. It doesn't matter if it's greater than or less than another. It's like we're going to consider like in absolute value. So the first way that we can measure deviation is by the mean distance. That is comparing the average of how far data are from the mean. So we would be taking the sum of each value minus the mean in their absolute value or in the modulus, and then we take the average. This is one that we're not going to be using quite much in A levels because it's not quite much used in mathematics, because it includes a very particular problem, and that is the modulus. The modulus is a function that may give us problem when we have many pieces of data. So from there, we're going to include the next one that is called the variance. The variance essentially works in the same way, but instead of using the modulus, is take the square so that all values are positive, but squares are easier to work with. Why is that? Well, first of all, because we have this beautiful formula here that also helps us to find the variance. You can take the variance by making the sum of each value minus the mean squared and then the average. That is this formula that is here. You take value minus the mean, you square that, and then you add them all together and you take the average. Or you can do what we call the sum of the squares divided the number of values minus the mean squared. These are the two formulas that we are going to look now at with an example so that you can look at it more clearly. And then there's a problem with the variance. The problem with the variance is that as we're squaring, we're changing the unit. So in order for us to go back into the original unit of the problem, we introduce the standard deviation, that is the square root of the variance is just that, so that we get to the unit, get back to the unit of the problem. So imagine that we're measuring meters, then variance is going to be meters squared, so that's not going to be that much helpful. So we take the square root and then we find it back into the unit of meters. So it's just that. Let's take a look at some examples so that we can see how this works in the exercises. We have this, well, before that, advantages and disadvantages. It is simpler to calculate once you get the hang of it. You can also do it in calculators. They do that if you plug in the data. You cannot do that for the A-levels exam, but there are calculators that can calculate that. We don't need to have data to be ordered. If things get more advanced, it's a little easier. We're using all the data. It is far more seen. That's one of the disadvantages, and it gives greater emphasis to large deviation because of the squares. Like if as deviation becomes larger, the square emphasizes that, so that is disadvantage, but just as comments. Now, yes, let's look at the example and see how we can work with this. We have find the standard deviation of the values that we have here. So I'm going to show you all two processes that we can do around this, and then well, you can choose the one that you prefer. So the first method will be using the formula that we have here, that I'm going to write down here. It would be the variance of x is going to be equal to the sum of x minus the mean squared over n. So observe that the first thing we need to do is we need to find the mean, right? It's because we have to use the mean, so we have to find the mean. I'm going to write over here that the mean, if we recall, if from previous videos, if not, you can go to the web page, or you can go to the previous video. You can easily calculate the mean by doing 12, that is the value of x, times 13, plus 14 times 28, plus 16 times 10, and that divided over 13 plus 28 plus 10. This I'm using the formula that is the sum of x times f divided by the sum of f. That is when we have grouped data in the mean. Again, if you don't remember about that, you can go to my webpage where I have everything explained, or to the video that I made on that topic. So, well, we do this beautiful thing and we get that the mean has a value of 236 over 17. Here we need to focus on the fact that if in this case, this fraction that cannot be simplified furthermore, and the decimal is not going to be exact, we have to use the exact value. So it may be a bit uncomfortable, but well, it's just what happens. So let's take a look at this. We have, okay, now we have the mean, we can look at the variance now. And as I told you earlier, I'm going to be using the first formula here. So in this case, the variance of x, how would we calculate it? Well, this would be the value of x, that is 12. I'm going to subtract the mean. I'm going to subtract 236 over 16. That I'm going to square it, and I should add that 13 times because I have 13 times the value of x. So again, I'm going to multiply that times 13. So it's 13 times 12 minus the mean squared. Next value, I have 28. 28 times is 14 minus 236 over 17 squared plus 10 times the value of 16 minus 236 over 17 squared. And all that is going to be divided over the sum of fraction, that is the sum of frequencies, that is 13 plus 28 plus 10. I'm not going to be making that now. You can do it in your calculators. Here you will be getting the value for the variance to be somewhat, I have it around here, it will be 1552 over 867. What's the other way around this? Well, the other way around this is with the other formula that we mentioned. The other formula is the variance of x to be equal to the sum of the x squared over n minus the mean squared. So what is the sum of x squared? The sum of x squared is essentially the sum of 12 squared plus 12 squared plus 12 squared 13 times plus 14 squared plus 14 squared plus 14 squared 28 times plus 16 squared plus 16 squared plus 16 squared 10 times. So how could we write that down? Well, that would be 13 times 12 squared plus 28 times 14 squared plus 10 times 16 squared. This is the sum of squares. Then that sum of x squared, we're going to divide it over n. What is n? N is the sum of the frequencies. So it's 13 plus 28 plus 10. And that we're going to subtract 236 minus 17 squared. So this is the other way around the formula. You can choose either the one on the top or the one on the bottom, the one you like. These are the two ways around this. I'm going to write it now. Yes, this is equal to 1552 over 867. And then we must remember that we are asked for the standard deviation correct to three significant figures. Standard deviation of x is the square root of the variance. It's a square root of 1552 over 867. We go to our calculators, we plug that in, and we get 1.34. That will be the standard deviation here. It is quite messy, yes it is, but it's not that difficult. It's just messy, and here, as I told you, I'm doing two methods in one. It's like, okay, we could just choose one or the other. I'm just showing you both methods. So this is for the first part of variation. We're going to move on to the second part that has to do with using variance and standard deviation in order to find some values like the sum of the frequencies times the values of x, and sum of the frequencies times the values for x squared. Like in this case, we are told that n is 25 The sum of x is 275 and the variance is 7, and we have to find sum of x squared. So go back to the formula. I'm going to write it here. Variance of x is equal to, and now yes, I'm going to be using the second formula, the one that says sum of x squared over n minus, and instead of writing mean, I'm going to write the formula for the mean, that is sum of x over n squared. Why is that? Because here I can say, well, the variance of x is just 7. 7 is equal to the sum of x squared, that is what I want to find, over n, that is 25, minus 275 over 25 squared. And from here, I can just solve for x, right? I just take the square here, I add them up, I multiply times 25, and I would be getting the value for the sum of the squares that I have it here. I'm not going to do L of the word, but it's going to be sum of x squared is going to be equal to 3,200. Again, if you want to take a look at the step-by-step process, I'm trying not to make these videos too long, so it's like I present to you like the new part and then you can work it out as well. If you want to see a step-by-step process, you can go to my webpage where everything is expanded there. So next thing we're going to see is what happens when we combine data. And when we combine data, we have this very beautiful formula that is here. The variance of x and y is the sum of the squares of x plus the sum of the squares of y over the amount of values of x plus the amount of values of y minus the mean squared. Again, sum of squares minus the mean squared. There's not much to do about it. It's essentially the same. So for example, let's take a look at this exercise. It's a very interesting example. It's quite concrete, so we'll try to go over it with no rush. In examination, we have 120 boys. So I'm going to start writing things down. The amount of boys, that is x, n of x, is equal to 120. And we have that the sum of x is 7,020. The sum of x squared is 424,320. Then the amount of girls, that's going to be ny, is 80. And we have the sum of y squared to be 350,130. What do we have to find? What is it that we're looking for? We're asked to find the mean mark of the girl. So we're looking for y over bar. Y over bar, that is calculated as the sum of y over the number of y's. We do know the number of y's, that is 80, so we need to find the sum of y. How can we do that? Well, we can do that by, first of all, using here we have the standard deviation. Remember that standard deviation of x and y is the variance of x and y in the square root. So if the standard deviation is 10, we can know that the variance is 100, right? So here we get that the variance of x and y, that this is 100. That's what we know. But then this is equal to our beautiful formula that we had here. There was sum of x squared plus sum of y squared over number of x plus number of boys, number of x plus number of y, minus sum of x plus sum of y over nx plus ny squared. So here we look at this and we know this is 100. We know this because this, we have it here. We know this, we know this, we know this. All of the data with x, we know it. And then we know for y, we know this one, we know this one, and we know this one. Sorry, we know this one, and we know this one. We know the sum of the squares. So from here, from this equation, we can find the value of sum of y. We go, we make some operations. It's going to take us a bit of time. Don't worry, it's common. But from here, we can find the sum of y, and once we find the sum of y, we plug it in here, and we get the, I'm talking about we plug it in here, and we get the mean mark for the girls. It's a very interesting problem. I recommend that you take some time to look at it, and if you need any help with it, you can go and also look at it in my webpage. Then, moving on, we're going to see what happens with variance where we are coding data. Remember that when we code data, we are transforming every value by adding or subtracting a number, and we have talked about the fact that the mean of a data set x minus b is equal to the mean of x minus b. This means that if we take a set of values and we subtract or we add the same number to every value, the new mean is the original mean minus or plus the value. The thing is that when variance is much easier, because with variance is the same. If we code data, the variance doesn't change. Okay, so from there, if we're given something like this, we're going to be using that the variance doesn't change. How is that? Well, let's think about this problem. This is a very interesting problem. I selected it because it's a very interesting one for us to work with. It's going to be the last thing I'm going to be doing for you in this video. So we have we're going to have that we have 8 values on x, so I'm going to start writing down that n of x is equal to 8, and we have the sum of x minus 10 squared and the sum of x minus 10. The thing is, we are looking for the variance of all the values together, so we're looking for the value of the variance of x and y, that is the sum of x squared plus the sum of the y squared, that is a horrible sum signal, over the amount of x plus the amount of y minus the sum of x plus the sum of y over nx plus ny squared. So we're going to see which are the data that we can start finding, right? So from here, and I'm talking about from this here, we can find the sum of x, because remember, this is something that we did in a previous video. Remember that we did this, that this is, if the sum of x minus 10 is given, we know that this is equal to the value of x minus 10 plus another value of x minus 10 plus, and so on, so on, so on. So this is every value of 10, every value of x is the sum of x, and then we are subtracting 10 8 times. Why is it 8 times? Because we have 8 values, so this is going to happen 8 times. So from here we can solve, because the sum of x minus 10 is 100. So from here we can find the sum of x. Okay, so this one that we have here, we can find it. Analogously, we can do the same thing with this one, because here we have the sum of y minus 5. The sum of y minus 5 is going to be equal to the sum of y plus 5 times 12, because we are given 12 values of y. So it's the sum of y, and then we have 12 times we're adding 5. So it's going to be plus 5, 8 times, 12 times we have that. So we can find that one as well. We know that this is a 12, we know that this is a 12, and we know that this is an 8, and we know that this is an 8. So the only thing that's going to be remaining here is finding the values of sigma squared x squared and sigma y squared. And that can be found by working with the variance. Let's take a look at the following. Sorry, I deleted everything. That's not what I wanted to do. I want to delete just this part here. The variance of x is calculated as the sum of x squared over n of x minus the sum of x over n of x squared. The variance of x minus 10 is calculated as the sum of x minus 10 squared minus the sum of x over nx over nx squared. The thing is that the variance of x and the variance of x minus 10 are the same. So these two expressions are the same. The sum of x squared over n of x minus the sum of x over n of x squared is the same as the sum of x minus 10 squared over n of x minus the sum of x squared over n of x squared. Then we know this because we found it in the previous part. We know this because we're told about this here. We know this, and this. This should be, sorry, here this should be an x minus 10. There, so we know it because we're given here in the task. So from this thing, this equation that we have here, we can find sum of x squared. Analogously, we can do the same thing with y. This would be the sum of y squared over n of y minus the sum of y over x squared. That will be equal to the sum of y plus 5 squared over n of y minus the sum of y plus 5 over n of y squared. Same that we can find this beautiful thing here, and then we can plug all that together and find the value for the variance. This is a very interesting problem. I recommend that you take a look at it. In case you want to know the step-by-step resolution, you can go to my webpage. You'll find the link in the description where it's already solved with this and more exercises. And as usual, thank you for watching. If you have any comments or any suggestions, please use the comment section below. And well, I hope to see you in my next video. Bye bye.